All right, guys, so we are back again. So as I was saying before, in order to calculate the probability of getting ahead and an ace in two independent events, what we generally do is multiply the probability of each of these events, multiply them together, right? So in this case, we're multiplying the probability of getting ahead, which is a half, times the probability of drawing an ace, which is 1/13. And so when we multiply them together, a half times 1/13, numerator, 1 times 1, give you back 1. Denominator, 2 times 13, give you 26. So the probability in the fractional form would be 1/26. And if you want to write the probability as a decimal, you divide the numerator, which is 1, by 26, and you would get the probability in decimal to be 0.038. All right, that's clear to everyone, right? Raise your hand if it is clear to you guys. All right. So we can move to the next situation. So we have a general formula for independent events. So this is the general formula for independent events. So for independent events, where we have event 1, event 2, event 3, up to as far as event n, where event n can be any number. To get the probability of these events, being that they're independent of each other, what we do, we just find the product of all the probabilities together. Is that clear? Raise your hand. So what we have here is the actual formula. So probability of event 1 and probability of event 2 and probability of event 3 all the way up to probability of event n, where to find the probability of these events, they are independent. So all we are going to do is to multiply the probability of event 1 times the probability of event 2 times the probability of event 3, go all the way up to the probability of event n. And that will give you the probability of the events based on finding the probability of all of these events. All right, guys? All right, so moving along. So that was independent events. And now we're looking at dependent events. Now, I'm going to read the definition for dependent events. And somebody going to tell me how the dependent event different from independent event, because they're actually different in terms of what is happening with the events. All right, so let me read the definition, and then somebody tell me how the dependent event different from independent event. So the definition here for a dependent event: if an event has an effect upon a subsequent event, then the subsequent event is dependent on the previous event. And so we call that event a dependent event. All right, so now you have heard the definition for dependent event. Can somebody tell me now how dependent event is different from independent event? Who wants to go? Shall I call on someone? Mr. Lamar, did you get that explanation?
Yes, sir.
Did you get the explanation for independent event?
An independent event, yes, sir.
And now we're looking at dependent event. So I'm asking the question, how are these two events different?
So if one has a direct effect on the other.
All right. That's a little vague, but can somebody else add to what Mr. Lamar is saying? Ms. Waysam, do you want to add anything?
No, sir.
Miss Green?
No, sir.
All right. Is anybody in agreement with what Mr. Lamar is saying? And can you explain why you're in agreement? Miss Green?
I'm in agreement, but I don't know what to explain.
Ms. Waysam?
Sir, I didn't hear his respond.
Mr. Lamar, would you like to go again and so that Ms. Waysam can hear you? Mr. Lamar?
Yes.
Yeah, just give the explanation. Explain how dependent event is different from independent event.
So with a dependent event, for example, you'd have two events,
right?
And one would directly impact the outcome of the other event.
All right.
An independent event where two events do not correlate, they have no impact on each other. So.
All right. So did you hear that now, Ms. Wilson? Can you comment?
Yes, sir, I heard.
All right. So are you in agreement with what he's saying?
Yes, sir, so far.
Okay. Miss Brown? Are you in agreement with Mr. Lamar? Are you hearing me, Miss Brown? All right, she's not responding. I'm not sure what is happening with her connection. Miss Cabrera, I realize you're a little late. Have you picked up on anything that was being said when you got in? I didn't hear what you just said, Miss Cabrera. A little bit. All right. Were you here yesterday when we were having this class?
Yes, sir.
Okay. But, so you remember we were talking about independent event and dependent event. So that was almost at the end of the class. So we're kind of just reviewing these ideas and reinforcing the concepts. All right. So Miss Dorothy, are you there? No, Miss Dorothy dropped off again. All right, so as Mr. Lamar was saying, is quite right. Now, for independent events, if you have two events, what happened in the first event does not affect the outcome in the second event because they have no connection. They have no correlation, as what Mr. Lamar would say. Now, and so because they have nothing to do with how the outcome occurs for the following events, then we say that the events are independent. Now, in this case, where we have dependent events, this is saying to us what happened in the first event will affect the outcome of any event that follows, or what we would refer to as subsequent events. So any event that follows from the previous event, the previous event will have an effect on the events that follows, right? Can anybody give us an example of two events that will have an impact? The first event will have an impact on the second event. Can anybody give an example? Go ahead, Ms. Raysom.
Sir, I'm not sure what I'm just trying. So for instance, in the case of playing what's this game called? Like even the same Ludi, sir.
Right.
And then so for instance, you throw the dice and you fall at the place, and then the second dice is thrown again. And then it would just fall on your spot, and then probably, you know, them so want to die would have throw on the spot where that player is, you know, that player would have fall off from the game.
All right.
So I don't know if I can use it in that.
So the event here would be throwing a die. But, but would that have anything to do with the movement of the what you refer to as the man around the board?
That's
Right.
what I'm saying, sir.
Right. So even though it affects the movement of the man around the board, the event of throwing a die one time does not affect the event of throwing the die the second time. So if the die is what the events are, then they are still independent. You get what I'm saying?
Yes, sir.
Right. Anybody else want to try to give an example of what happened in a dependent event? All right, so let me give an illustration of what happened in a dependent event. All right, so I want to use some drawings so as to help you to see what is happening. All right. So let's say we have a box with some marbles. And let's say we have 1, 2, 3, 4 green marbles. One, 2, 3, 4, 5, 6, 7 blue marbles. And we have 1, 2, 3. Well, let's call that orange marbles, all right? All right, let's say that we are looking at the probability now of drawing. So we are looking at two events. We're looking at a first event of drawing a marble, and then a second event of drawing another marble. Now, suppose we have two events. So event one, we want to find the probability of drawing. What would be the probability of drawing a green marble? and I'm going to use G for green. What's the probability of drawing a green marble in event 1? And then we have a subsequent event, which is event 2, so the event that follows. Now we want to find the probability of drawing a blue marble. All right. Now my question is, can event 1 affect the outcome of event 2?
Yes, sir. Because you might want to draw blue and happen to draw green.
All right, not in terms of, remember when we're dealing with the probability, we're looking at how many favorable outcome out of a total possible. So whether or not in drawing a marble we get a green or a blue or what, that doesn't matter with the probability. The probability is how many chances of getting a green marble by doing a draw. What is the chance of getting a green marble? So you would measure the probability by looking at, all right, let us do the probability of getting a green marble. So the probability of getting a green marble would be equal to what? Anybody?
4 out of 14, sir.
Right. So the probability of getting a green marble is really based on how many green marble in the box. So we have 4 green marbles in the box. So we get 4 out of 14. All right. Now, what would be the probability in the second event if we are drawing a blue marble?
That's what, 7 out of 14, sir.
So the probability of getting a blue marble in the second event, and remember guys, we use PR for probability. So even though I'm just using P here, it's just for convenience. So PR for probability. So the probability of getting a blue marble now, if in the first event, when we draw the green marble, we took that marble out and did not replace it in the bag, would it affect the probability of drawing a blue marble? So if you're, all right, if you think of these as fruits, right? And all of these are fruits. So you have green fruits, blue fruits, and orange fruits, right? So let's say that you took a green fruit out of the box and eat the green fruit, right? Now the probability of eating of taking a green fruit would be 4 out of 14. But now what would happen now in the probability of eating a blue fruit? What would be the probability?
Would it be 7 out of 13, sir, since it was not replaced?
It would be 7 out of 13 since it was not replaced. And in this case, you would have what happened before in event 1 would affect the probability of event 2, because whereas the probability of event 1 is out of 14, the probability of event 2 now is out of 13, right? Now, and that happened because you took out something out of the box and you did not replace it. So every time you take out something out of the box, it decreases the total of what was in the box. And if you're not replacing it, when you're calculating the probability of the next outcome, it will affect the outcome. And in this case, we call it dependent event. So what is key about this scenario is that if you take one of the object out of the box and don't replace it, then the next event will be affected. And so this is when we have a dependent event, because what the probability of the event that follows is going to depend on what you did in the first event. So that's why we call it dependent event. So how do you know when you have a probability dealing with dependent event? So if you, in this case, draw one of the marbles or one of the object and don't replace it, then you know you're dealing with a dependent event. Because the next event will now have a new total, which will, the next event will depend on that new total. So that's why it is that's why it is dependent. All right, guys, is that clear to you?
Yes, sir.
All right, is it clear to you? Everybody, let me see your hands if you're okay with the concept of dependent event. All right, good guys. Now, for dependent event, the probability of one event and the next event is calculated in the same way as how we calculate independent events. You simply just multiply the two probabilities together. The only difference here is that what happened in the first event will affect what happened in the second event. But the probability for A and B, if the event A and B occurs, so event A occurs first, B occurs after, even though the probability of event B is affected by the probability of event A, we're still going to calculate the probability of A and B by multiplying their probability. Is that clear?
So go over that again, please.
All right. So in the independent event, when we are calculating probability of A and B, we multiply the two probabilities. You remember that?
Yes, sir. For the independent event, yes.
The independent event. And in the same way, when we are calculating the probability for dependent events, we still multiply the two probabilities.
Okay.
So it is done in the same way, right? So the only difference with them is the second event for the dependent event will give you a probability that depends on what happened in the first event. That's the only difference. But when we're calculating them, we do the same thing by finding the product. All right. Now, so it is important that we are clear as to what we are doing with, because you have learned about 4 different concepts as it relates to events. We talk about mutually exclusive events. We talk about non-mutually exclusive events. And we talk about independent events. And we talk about dependent events. Now, each of these event type, you must understand them conceptually, what is happening in each of them in order to address them. All right, so let me point out some things that are important. So for mutual and non-mutual events, let us start with mutually exclusive event. For mutually exclusive events, we use or. So we are finding the probability of A or B. So in that scenario, when you have a mutually exclusive event, it is the same when we are saying what happened in the first event does not overlap with what happened in the second event. So in that case, because we are finding the probability of A or B, we simply just going to add the two probabilities. Is that clear? That is for mutually exclusive events. So in mutually exclusive events, if we look back at what the Venn diagram was, the probability of A would be this circle, and the probability of B would be this circle. And so what happened with probability of A is separate and apart from what happened with probability of B. So they are mutually exclusive. All right, mutually exclusive is kind of similar to being independent, right? But mutually exclusive means that the two things cannot occur at once. So if you're drawing an ace and you're drawing a jack, the two events, drawing an ace and drawing a jack at the same time, right? Remember now, for dependent and independent event, you have subsequent event, one event followed by a next event. But for mutually exclusive event, we are talking about one single event where can we get two outcomes that are different or that are not connected in one single event. Like in a single cut off a card pack, can we get a jack and an ace at the same time? And the answer would be no. And because you cannot get them at the same time in a single draw or a single event, we say that they are mutually exclusive. So I want you to have it clear in your mind what we mean when we say mutually exclusive. It is referring to getting two outcomes in one single event. So if the two outcomes cannot happen at the same time, we say that they are mutually exclusive. So in the case of drawing an ace and a jack in one draw, we can't get the two of them at the same time. So if we are trying to find the probability of A or B in a mutually exclusive event, what we generally do to get the probability of A or B and notice we're using the word or between them. So in this case, what we're really doing, we would have to find the probability of A and then we add that to the probability of B. Is that clear? And that is for what? Mutually exclusive events. So make sure you understand when you are dealing with mutually exclusive events, that's what happened. All right, guys, just forgive me with the writing. So this is supposed to be mutually exclusive events. All right, so is everybody clear as to what happened with a mutually exclusive event? Because the outcome in a single event cannot be two outcomes. So what will happen in that case? You can either get one or the other. And so if you are finding the probability of A or B, we simply just find the probability of A find the probability of B, and then add the two probabilities. Is that clear? For mutually exclusive events. Is that clear, guys? Raise your hand if you're following what I'm saying. All right. I see where some persons are not responding. Does that mean that it's not clear what is happening with mutually exclusive events? All right, guys, if you want me to go back.
In that part of it. Due to how I was keep on dropping off after rewatch the video.
All right, Miss Dorothy, your connectivity is kind of bad, so I'm not hearing exactly what you're saying because the audio is a bit slurry. So, but if you guys are not understanding mutually exclusive event, I can always go back to review it so that you get it clear. But just want you to know, is everybody clear with dependent event and independent event? Raise your hand. All right. So what I'm really trying to do now is to really show you how dependent and independent event, I'm just trying to show you how they are different from mutually exclusive events and non-mutually exclusive events. So if you want me to go back to those slides, I will just go back for the sake of reviewing. All right, so let me see if I can go back to them. All right, so here, in this case, we refer to this as mutually exclusive events. And based on the definition here, we said two events are mutually exclusive if they cannot occur at the same time. All right, so in a single, so it's basically a single event you want to get two results in one single event, so to speak. So in other words, drawing an ace and drawing a king, there are two events that you would like to occur in one single draw, and that cannot happen. So we say that they are mutually exclusive. All right, here's an example that they are saying here. For example, a 3 and a 4 cannot occur in a single roll. So if you want to get a 3 and a 4 in a single roll, those are mutually exclusive because it cannot happen in one single roll. So in that case, from that roll, we can have one or the other. So in a single roll, we can either get a 3 or a 4. And in that case, we are trying to find the probability of A or B. And in that case, if we are finding the probability of A or B, then the way to calculate it is to add the probability of A to the probability of B. Is that clear, guys? And that has to do with mutually exclusive events. Now, drawing a jack and getting a king at the same time in a single draw is mutually exclusive because you can't get them in one single draw. All right. Now, as you notice, the Venn diagram for mutually exclusive events, they are disjoint. That means they can't happen at the same time. All right. So this is an example of mutually exclusive events. So the probability of getting a 3 or a 4, because both of them can happen at the same time in a single draw, we would have to find the probability of getting a 3 and the probability of getting a 4, which is 1 out of 6, and 1 out of 6 for the 4. So we add the two of them to get the probability of 3 or 4. And that is why the word or is used, because we are dealing with mutually exclusive events. A second. So is that clear with mutually exclusive events? Now, for mutually exclusive events, the two events cannot happen in a single roll or a single draw, right? So if we are dealing now with non-mutually exclusive events, it means that if it is possible for two events to occur at the same time, then the two events are non-mutually exclusive. So once they can happen at the same time, it would be non-mutually exclusive. So it means that you can get, in the event, you can either get one or the other, or you can get both. And in non-mutually exclusive event, this is how you calculate them. You would add the two probabilities, probability A plus probability B. Then you would find the product of the two probabilities. Then you take away the product from what you add. And that's how we calculate non-mutually exclusive events, right? So for non-mutually exclusive events, you have a overlapping with the diagram because you have a part where both can happen at the same time, which is the intersection in the Venn diagram. All right, this is an example of non-mutually exclusive events. So if event 1 is the event of drawing a jack, event 2 is the event of drawing a diamond from a pack of cards, find the probability of drawing a jack or a diamond or a jack of diamonds. Now we know that there's a card in the pack which is a jack and a diamond at the same time. And we call it jack of diamonds. So it means that we can either get a jack when we're drawing, we can either get a diamond or we can get a jack of diamonds. So the probability of getting a jack, we have 4 jacks in the pack, so it's 4 out of 52. The probability of getting a diamond, we have 13 diamonds in the pack, so we have 13 over 52. The probability of getting a jack of diamond is only 1 jack of diamond in the pack. So we would have, we would have this jack would occur in the probability of jack, and this jack and this diamond would occur in the probability of diamond. So what we do now to get rid of this overlapping, we add the two probabilities, 4 over 52 plus 13 over 52, and then find the product of the two of them, 4 over 52 times 13 over 52. And then now, once you simplify the sum, we get 17 over 52. Once you simplify the product, we get 1 over 52. So we subtract 1 over 52 from 17 over 52, we get 16 over 52, which